All right, let's get started. Good morning, everyone. My name is Justin Incarnato, and I'm a program manager on the Azure Stack team. And today I'm going to talk to you about how we service the Azure Stack appliance end-to-end. This will be an interactive session. I know I only have 40 minutes, and I have a ton of content to go through, and I can't run long like I did in my theater session yesterday. So I will absolutely hang out after the show and take any questions that you have. And if you could, pay particularly close attention to some of the bullet points that I'm going to fire off at you all. I've got 2 Azure Stack t-shirts. They've only been washed once. I haven't worn them, so I hope Tide is okay. They've never been worn. A couple quick questions. Whoever answers the questions, I'll hand out the t-shirts. I know it's not the coolest swag in the world. I hope you wear XL. If you don't, use it as a night shirt or whatever you want to do. So again, thanks again for taking the time. My Twitter handle is @JustinInc. And for more information on Azure Stack updates in general, you can just go to AKA/MS/Azure Stack Update. So hello and good morning. Hello, how's everybody doing? No, it's too early for that. I hope you all are having a good morning. You've had plenty of coffee. Again, my name is Justin. Today we're going to talk about the problem space. Azure Stack is an appliance, and we're going to talk to you about how we service this appliance. And this will be everything from the physical hosts all the way up through the XRP rings and all the service fabric rings, the service fabric runtime, the microservices, all the way up to all the artifacts in the control plane that actually allow you to enter through ARM. So we'll talk about some of the single instance VMs, some of the domain controllers. We'll talk about the different rings that we have. We'll talk about our strategy to update those service fabric rings, some of the native Windows rings, some of the traditional service fabric rings, the hosts that live on the agents that live on the hosts, how we do live migration, how we do maintenance, storage rebalance, all the good things in between. But first we'll talk about, again, the problem space. Why is this a problem? Then we'll talk about what we built. What we built, how it's native, how you run it, how you manage the updates. We'll talk about managing the updates, the next bullet. And then looking ahead and more information. So more information about things to come as far as the update resource provider is concerned. Looking ahead to some new features that we've got your feedback on, things we want to implement. We'll talk about the deferral policies, what it means to defer updates, how you ingest updates, again, how you manage them, how you do it through the UI, how you do it from PowerShell, which is cool as well. And then I'll show you a demo. I'll flip over to the demo rack. Hopefully I can connect to the demo rack because all the PMs on our team are using it, but if not, I've got some good screenshots as well. I'm going to show you what the portal looks like. We've designed it to be extremely easy. It's the same friendly UI that you've seen if you're an Azure customer today or an Azure user today. But remember, in Azure Stack, there's a whole host of operations that you need to perform that you don't necessarily need to do in Azure, right? Things like setting up your plans, offer subscriptions, monitoring Azure Stack, field replacement units, so if something burns out, you can replace it easy, patching, monitoring. All these things are now in the hands of the operator, you all, as Azure Stack operators. And we'll talk about some of the differences between managing an appliance and the traditional administrative roles that we are used to today. So, been with the company almost 19 years, 5 kids, 1 wife, huge college football fan, so we can talk about that also as well if you're not interested in talking about this. So let's talk about the problem space. Security is paramount, right? I don't need to stand up here and preach to you all about how important security is. So just know that every month I will release to you all, or release to our OEMs, an update package that contains the security payload that traditionally goes on Windows Server. You'll have the Patch Tuesday security bulletins and KBs that go out on the 2nd Tuesday of the month. You'll also have the updates that come out on the 3rd Tuesday of the month, the latest cumulative updates. The latest cumulatives roll into the next Patch Tuesday security payloads. We will always ingest those security payloads, and I'll stuff those into an update package as well as NuGets for our other resource providers. So other updates for Azure Stack components that are native to Azure Stack, like our own compute resource provider, our own network and storage providers, the update resource providers, the backup resource providers. You know, insert your RP here. We will be responsible for updating those as well. So keeping it functional and adding functionality. The URP stands for Update Resource Provider. Sometimes I refer to it as the umbilical resource provider. All updates that transfer from Azure into Azure Stack land on the system via the URP. The URP is native to Azure Stack, and we'll talk all about that today. So again, any updates, any security updates, and any features that are going to roll down from Azure come in via the URP. That's the only way that we update Azure Stack. And it's one simple interface that I'll show you all in just a few minutes. Some of the other column, who likes to be assigned to patching on the weekends? You know, kind of keeping your fingers crossed. The one guy I talked to yesterday, I don't believe you and I don't believe you. No one likes to do it. It's about the least sexy thing you can do in IT, but it's absolutely critical, right? We have to get these security updates out. We have to get these functional updates out. And one of the things you want to make sure that you do is don't be disruptive to my applications or services, right? And so we take advantage of things like live migration and maintenance, and we'll talk more about those in just a few minutes. But that's kind of our P0, right? Update the stamp, and we do it slowly, and we do it safely, because we do a lot of things in serial, right? And I'd like to believe that you don't care as much about how long it takes if we're non-invasive to the workloads. It just kind of happens in the background. And we'll talk about telemetry data that I want to collect to allow me to give you a better estimate about how long that takes, and we'll talk more about that. The question is what to install, how to install, where to download these things, who to call if there's a problem, what to download. In just traditional suites, you've got updates from Windows Server, you've got updates for SQL Server, you've got updates for the hardware, you've got update from the drivers, right? And they're all on a different cadence. Have they been tested together? Have they been validated together? Is there a particular order that I need to install them in? Who do I call if there's a problem? Again, ensuring business continuity to make sure that we can update in the background, kind of a background task, where you can still have access to the portal and still have access to those workloads, right? That's the key environment. Now, there's a caveat to that. Some of the instances that we have in Azure Stack are singletons, right? In the control plane, where you enter through ARM, there's an administrative interface, and that's one instance, one infrastructure VM. So when we bounce that VM for the 7 to 8 minutes it takes to service that VM and bounce it, right? Administrative functions may not be available, right? But there's 2 portal VMs for our tenants to enter in. We'll service those one at a time, of course. So you'll be in a bit of a degraded state, but you still have 2 portals available. So some of those singletons, there's not a lot that we can do about. We can add to those in the future if the architecture's right. So one package, one signature. I will notify the OEMs and also on my Twitter handle, hey, an update's available for Azure Stack. 1710, 1711, and that's just year, month, and I'll show you what the version string looks like. We'll release in October, we'll release in November, we'll release in December, we'll release in January. OEMs will then notify their customers, hey, thanks for purchasing Azure Stack. By the way, Microsoft's released an update. Some of my OEM friends are in the front row here. Released an update for Azure Stack. Go get it. We'll host it on an Azure download page, download it, and import it into the system. And I'll show you what that import process looks like and why it's important. We'll sign it to make sure that no one ingests any update that we haven't built ourselves. The URP will only invoke signed Microsoft update packages. Our OEM friends, for driver updates, will build OEM extension packages, which are just driver update packages, very similar to our software update packages. Say, hey, these look good. Hand them over to us. We'll sign them, hand them back. We're their customer 0, you all are customer 1. Hand them back and they can put them on their download center. We will release monthly. The cadence to which the OEMs release varies, and it depends on the OEMs. It's up to them to decide when those release. We will never block ourselves on a particular OEM version for security payload. Those go out, those can be ingested, those can be imported. There's no dependencies. OEMs, on the other hand, can declare a dependency. They can say, hey, Justin, we're going to release this 1.4 fictitious version. It's a signed package, it's a driver, and we've validated it with Microsoft's 1711, right? Because there's an intersection between the OS and the drivers, of course. So we want to make sure that we've validated what platform and what version of Azure Stack is validated with their package. And there's more details on that later. So the net of this is just focus on other aspects of the business. Go out, go sell Azure Stack, right? Let the meters spin, right? Sell your services, right? Dispense your VMs, do your IaaS, do your PaaS, right? Let those things happen naturally. You don't have to focus on the patching and the update space, right? Just invoke the update and kind of let it go. And we'll monitor progress, and there's download logs, and you can look at things, and I'll tell you what to do if something goes wrong, and we'll talk all about that in a few minutes. But again, all those artifacts there, the kind of net of it is go focus on other aspects of the business. So let me talk about what we built. It's a long sentence, but it's a built-in dependency-aware orchestration engine, right? And it updates the physical hosts. It updates all the XRP, all the service fabric rings, and updates the control plane. So all the physical hosts, again, and all the agents that live on those physical hosts, the NC agent, the SLB agent, right? The monitoring agents. All the artifacts that live on the hosts, the service fabric rings. We have 4, right? There's an XRP service fabric ring that hosts CRP, NRP, SRP, compute network storage, update resource providers, all the resource providers. There's 21 microservices that live in that XRP ring. And so when we update a ring, we have to think about 3 things, right? We update the underlying OS that participates in that service fabric ring node, right? 1 of 3, 1 at a time. We update the service fabric runtime itself, and then also the applications, right? And so it's not just about, hey, let's just go point to moo and Windows Update and just let it fly. There's a very particular order in which things have to be updated. And that's kind of the secret sauce, if you will, right? We kind of abstract that away from you all, again, so you don't have to worry about it. The last part we update is also, so again, all the infrastructure VMs. Some of them are singletons, right? Like we talked about earlier. Some of them are like domain controllers, right? That are pinned to each physical host, and there's 3 of them, right? We'll never update all 3 at a time, right? We'll do those things in a very particular order. Last part, the highest part, the control plane, right? The WAS interface, if you will. 2 infrastructure VMs responsible for tenant portal access through ARM, 1 at a time. The OS and also the application itself, right? That web service. And then the infrastructure VM responsible for the administrative portal, right? Again, when we update that, the administrative portal is going to go down for a few minutes, right? So it's critical that you all set negotiated maintenance windows with your customers, because while we don't anticipate disruptions to your service, the particular VMs that are part of your workloads that you've given out to customers, it could happen, right? Because live migration, one of 3 things will happen with live migration, and we'll get into more details later. Graceful live migration, and Mark 1 moves over to host 2. Mark 2 moves over to host 3, right? And it's just graceful. Not like he's not graceful, unlike him. The VMs will live migrate, and if it can't live migrate gracefully, it'll do quick, right? So we pause, move, resume. That's in a matter of seconds because we're all hyperconverged, right? So we just put it on a different shared storage, right? That shouldn't disrupt your application because it happens in a matter of seconds. Now, there could be a scenario where we are unable to power off that VM, or we're unable to move it, and we'll actually power off that VM. And so we've got things like the 4 strain parameters attached to our cluster migrations, right? And that will power off the VM. And 9 times out of 10, I've seen if a VM won't power off for some reason, it's probably not going to power on the node that it lands on anyway. At that point, the update's going to stop and say, hey, I'm trying to do this, something happened, go investigate it. And you can look at the high-level logs, get into the privileged endpoint, troubleshoot that issue, and then resume your update. And it's proper checkpointing. And so if that step failed at step 22, we'll pick up at step 22. And there's about 25 steps total that I'll show you in one of the other slides. It's not the most interesting slide you've probably ever seen, but at least you can see things we do like update the updater first, then update cloud, go into the physical hosts, go into the service fabric rings, a particular service fabric ring, go through the agents, and I'll iterate through what that process looks like. So we don't need any outside tooling or integration, right? This is all built in. The only thing you need to do is go download the update package and import it, and I'll show you what that looks like and why that's important. That lends to itself to supporting the disconnected mode, right? The fact that you're using Azure Stack in a lot of cases tells me that you have data sovereignty concerns, or you're the United States Navy and you're in a literal submarine, right? And you're not connected. Or you're on a cruise ship and you've crossed that plane where satellite communications is no good And that bandwidth is exclusively for customers to update their Twitter feeds and take pictures of their food and post it on Facebook, right? That's a pipe that is fully saturated, right? So the last thing we want to do is require any sort of connectivity. Now, you need to have connectivity to go download the package, but that's it. Last part, the operators determine the maintenance windows and update installation time. And we'll talk about the deferral policy in just a few minutes. But just make sure that you negotiate those service windows just like you do for your other applications and services when you service the physical host or any appliance in your infrastructure for that matter. You choose when the update happens, right? You'll literally go into the portal and click a button that says update now, and it'll just start iterating through the update workflow. You choose when that time happens. And I'll talk about how long that takes, because there's a couple vectors involved when it talks about how long an update runtime will actually take. And I'll talk about what those are. So we've got the managed software updates provided by us. Again, we'll sign those, hand them out. The update resource provider will parse those. And we do things like cloud health checks. Right? How many times have you tried to apply an update and it just failed right away because WinRM was busted, or the cluster health was bad, or some VM that you expected to be on was off, right? That stuff happens. And so we're going to do a health check up front before the update and just say, is the cloud in a state that it can take a update successfully, right? And 9 times out of 10, that thing's going to pass. But if it doesn't, it's going to bark back at you and say, hey, one of your hosts is offline. And you can instantiate things like the field replacement unit, replace that node, then start again. Right? So we're going to do those health checks up front. When we update the physical host, for example, we'll say, hey, physical host 1, let's put you into maintenance mode. Maintenance mode says, let's evacuate all our groups. Hopefully it's a graceful live migration and all the infrastructure VMs, part of subscription 0, right, ours, move somewhere else, and all the tenant VMs, yours, right, move somewhere else as well. We'll do the live migrations, it's graceful. Once that physical host comes back up, there's a bunch of IOPS that have queued up in storage. Based on the amount of workloads you have, that IOPS could be big, it could be small. When that physical host comes back up, before we move on to the second host, we want to rebalance storage and say, you know what? This cluster node is caught up with the rest of its nodes in its peer nodes in the cluster group. We're ready to go. We're going to check our virtual disk health to make sure that all our VDs are online and reporting up is healthy through spaces. And then we're going to evacuate maintenance mode. And until then, we don't move on to that second host, because in a 4-node scenario, we have to think about things like reserve capacity, right? P&U aside, and that's patch and update, that's just a quick acronym. P&U aside on Azure Stack, if we lose a node, it just catches on fire and burns out. We need to make sure that we don't allow you to create more VMs than you can handle running on 3 nodes. And we do that for those 2 reasons, right? The FRU scenario and also P&U. We want to make sure that it happens. Now, when you get into larger increments of 8s and 12s, things like that don't matter as much. Anti-affinity rules don't come into play as much, right? If you've got a 4-node cluster, you've got node, 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 guest, 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 guest. We have to be soft with our anti-affinity rules when it comes to situations like that. So there will be a time when one of those guest VMs is paired up with another guest VM on the same host, right? Because at a 4-node system, physics is involved. We have to make sure that we can evacuate those groups and put them somewhere. And so again, you're a bit exposed at that point. Not a big deal, but just things to consider. Again, in situations where you have 8 nodes, 12 nodes, and then when we support nodes greater than that, affinity, anti-affinity, soft anti-affinity, live migrations, reserve capacity, those things don't come into play as much. But they do in a 4-node system, so just keep that in mind. Our OEM partners will manage the driver updates. Again, driven by the URP, signed by us. They build those and say, hey, Justin, great, here you go. We'll validate it as customer 0, hand it back, sign it. Firmware updates are managed by the OEM HLH, right? If you buy a 4-node system, there's this 5th node that each of our OEM partners manage the firmware updates with. And that's their tool of choice, right? That's their responsibility. They own that. Very similar to the switch management, right? P&U is not going to update the switches. So you'll have a close relationship with some of our great OEM partners who are responsible for doing things via the HLH, particularly the firmware. Drivers, because there's an intersection with the OS, right? We're going to DISM inject those drivers into our library images. So if a node dies for whatever reason and comes back up, we not only DISM injected the software updates into that library image, but we've also DISM injected the drivers into that library image. So if you guys are a 4-node cluster and you fall over for whatever reason, once you come back online, you're equal with the rest of your peers. And that just makes good sense, I think. So managing updates. So there's 3 things that you need to do. You need to download these, you need to import them, and then you need to run them. And I'll show you what that looks like. And so you'll get a notification from your OEM that says, hey, you know, Justin and the Azure Stack team built an Azure Stack update. It's available for download. It's ready to go. I'll blast it out on my Twitter feed as well, so you all know, hey, an update is available at Justin Inc. You guys can follow me there if you want. I'm not the most pervasive person who tweets, but I'll at least put those on there. So you'll see those. And 3 things that you'll update, that you'll import. There's a manifest.xml, which expresses things like the name, the state, the size of the update, the prerequisites, the support URL. Right? Stephen, if you get a download from me, you're going to go, hey, great, Justin, thanks for that. What's in it? Why do I care? Right? Tell me about it. Socialize that with your team, set your maintenance windows, and install it. Right? This is cloud, so we want you to stay current, especially in today's kind of security world, right? IT, we've just been getting our you-know-what's handed to us over the last few months, right, with everything going on in the world. So we want to make sure that, you know, security is paramount. We're going to blast those updates out there. Take them. Right? There's a deferral policy that I'll talk about in just a minute. Manifest.xml, the signed exe, and the corresponding bin files that express the payload. And I'll talk to you about what's in that payload. Right? And unlike traditional administrators like you all and I have been for a long time, or if you're new to IT, welcome. Logging on to administrator as administrator in Azure Stack, that world has changed, right? This is an appliance. You're on as an operator, right? And we won't allow anyone, even me when I log on, right, to get to the infrastructure file shares, where the VMs live and the tenant VMs live, right? So you have to log on to the portal, go into storage, create a container, and upload via blob service. You'll upload the metadata.xml, the signed executable, and any corresponding bin files. And out of the gate, you're going to have at least 1 bin file, right? Because I told you we were taking the full updates from Windows Server, right? That guy's about 1.2 gig as it is today, right? These are cumulative big monster updates. Monster's not a good word. These are very nice cumulative updates for Windows Server. Those are about 1.2 gig in size. Also, the NuGet packages that express updates for Azure Stack software, CRP, NRP, SRP, URP, BRP, you know, insert your letter here and add an RP to it, right? All the NuGet packages, and that stores about 700 megs. So these 2 packages aren't huge, right? 2 gigs about out of the gate. So when that submarine comes up, or that ship docks, or that satellite lands, or whatever happens in the disconnected mode, you need to have about 2 gigs worth of space, walk it over, and import it through the portal, and go from there. And I'll show you what that looks like. Again, talk to your customers, set your maintenance windows. There's 2 vectors that determine runtime. So when they say, hey, Justin, great, man, how long do I set my maintenance window? It depends on 2 things. One of the things we know about, payload, right? We know that there's a 1.2 gig artifact that needs to install on every physical instance and every virtual instance. In live migration, depending on your workloads, right, that's the second vector, workloads. Moving 20 VMs off of a host is a very different math equation than moving 200 VMs as far as time's concerned. And so it really just depends, the answer. In my labs, in my testing, in our OEM customer validations, we see anywhere from an hour and a half to 2 hours per physical host. And some people say, wow, Justin, man, that's a long time. Why? Well, there's post routines, there's all the health checks we do on the front end, there's the update process itself, there's storage rebalance. Again, that's a variable. and then there's the virtual disk checks on the back end, and then the health checks on the back end as well, the final ones, just to make sure that we've returned that cluster node to a healthy state before we move on to the second one. We would never want to start servicing host number 2 until we were absolutely sure of a couple things. One's as good or better than we left it. It's healthy, ready to go. Then we'll move on to the second one. Now, I will be collecting telemetry data for customers that opt into sending us telemetry data. So I can say things like, based on this workload and based on your profile, right, you traditionally run 50 VMs. This will take actually about an hour and a quarter per physical host. But you, on the other hand, Stephen, you're running 400 VMs, right? So based on your profile, it's going to take about 2 hours per host. And so keep that in mind when you think about how long to set your maintenance windows. And again, we do things slowly because we want to do them safely, but they are done in serial. Now, when we start to get things greater than 12 nodes, right? We talked about affinity, anti-affinity earlier. When we get into things greater than 12 nodes, we'll investigate, we'll implement ways to do things in parallel, right? Where reserve isn't as much of a big deal. Anti-affinity isn't as much of a big deal, right? The FRU scenario, not so much of a big deal. We've got more room to put these VMs and kind of divvy them all out amongst these other hosts, right? So in a 4-node scenario, we can only service one at a time because if we do more than that, we're going to break reserve. In a 12-node scenario, in a 24-node scenario, in a 36-node scenario, right, we can do those servers, those physical hosts, in parallel. And those are things that we'll do. So you can install the updates and monitor the update progress. Very simple through the UI, hit update, it says in progress. Go to the top level tile, it says in progress. You can download full logs and look at all the steps that are involved in the update process. Again, there's about 25 that we have today. Repeat. Right? Every month, you know I'm going to give you an update package that has at least that security payload. If, you know, what's the latest one? WannaCry, right? That one made me want to cry, right? If WannaCry v3 comes out, WannaCry v4 comes out, we will update a fix for that as soon as the MSRC, the Microsoft Security Response Center, releases an update for Windows Server. We will turn around and ingest that update within 72 hours and provide it available to our customers. We'll make sure that, now that won't get the full rigor testing that we do for the monthly updates because we've got a whole month to test it and validate it, make sure it's good. But we'll do the same for any out-of-band 0-day security exploits. Our OEM partners will do the same thing, and we hold them to the same bar. Last note there. This is cloud, keep it current, right? Use the umbilical. We understand there are situations when you cannot install updates, right? It's risky. You have policies that say you can't do it November, December, right? If you're a big retailer, for example. We understand that. Just note a couple things. You can defer up to 3 months and still call in and get support. But if you call in and you're running 1709, 1710 comes out, 1711 comes out, 1712 comes out, 1801 releases and it has some killer new feature from that umbilical that says, man, I really want to take advantage of this. Well, guess what you're going to be doing for the next few hours? You're going to install 1711, you're going to install 1712, you're going to install 1801, then you can take 1802, right? These updates today are not cumulative. That's our own problem to solve. Windows has done it with their cumulative updates. We have a technical opportunity to make sure that we can do updates east-west with our RPs and also north-south. And it's not so much the binary update as it is some schema problems that we've got, or schema opportunities that we have to make it better. So just note, 3-month deferral, you can defer, we understand, we get it. Try to stay current if you can. If you don't, you'll have to pay a sequential tax, for lack of a better term. So just keep that in mind. So if you're not a UI person, you can do this from PowerShell. Here's the GitHub repository where you can download that module. Here are the different updates that you can run, or update commandlets you can run. Git update location. This is, what version am I currently? Tell me about that. What updates are available? Okay, great. Install one. Okay, tell me how it went. Tell me how it's going. Right, so if you're not a UI person, I get it. Do it from a command line. right? You could create jobs to do this if you wanted to. These all go through ARM just like anything else. Update package composition. We talked a little bit about what is in these things. We'll ingest it through the blob service. There's an exe, corresponding bin files, and the metadata.xml. Again, the metadata.xml is responsible for parsing properties of the package. Name, size, prerequisites, support URL. And the Azure Stack packs themselves, what will actually be in these things? The package, the latest cumulative updates will have the Windows KB in it. N is for the NuGet packages. Again, the latest cumulative updates, there's about 1.2 gig in size. The NuGet packages that express updates for our particular applications, right? CRP, NRP, SRP. Those are about 700 megs. Those will both grow in size. From 1607 until today, the latest cumulative update for Windows Server has gotten 1.2 gig, right? And so over the next few months, I suspect that gets bigger in size. There's a custom action plan that says, what is the order of update I'm going to take? And that custom action plan expresses just that. The action plan we're going to pass over to our enterprise cloud engine that Chung built and parses our update action plan. So the metadata.xml, it's very simple. You look at things like the string version. Major version, minor version, year, month, day, dot build. You'll see that version string in the Azure Stack portal. You'll see that version string reflected in our update packages. You'll have an update description. You'll have a link to get more information. And you'll have that minver required, right? And so if you're at 1710 and you want to take 1712, what do you need to, you import 1712, it's going to go, oh, not so fast. Go get 1711, install it, then you can take 1712. This is the actual ordering a step. Again, this is not the most interesting slide you've probably ever seen, but these are the 25 steps that we take today that express an update package. Starting with pre-update cloud, the seed rings, service fabric, generate our base images, right? This is the literal order that we take. And when you run Azure Stack Update, there's a download full logs button that I'll show you in the UI that expresses this exact manifest. So no secret sauce here. You can download this at any time. You can always ping me and I can send you a copy if you're interested. This is the kind of stuff I'm interested in, right? Show me the steps that are running. Show me the steps that have completed. How many more steps do I have to run? And you can get some visibility there. So looking ahead, again, we're going to have monthly security payload that we hand out to you all that you can absolutely ingest. We'll have feature updates. Remember the URP, even though it stands for Update Resource Provider. Sometimes I call it the umbilical resource provider. That's probably just because I have 5 kids and I'm used to that space. Scheduling updates using the automatic mode, right? And so give me the ability to just check some box. And we've got some cursory designs on what that looks like. But a box that says just schedule the updates. And so once the URP has a border to get out and check that endpoint, it can say, oh, I have 1709 available. I see that 1712 is available. Well, guess what I'm going to go get first? I'm going to go get 1710 first, ingest it through the blob, transfer it to the infrastructure file shares, parse it, run it, and give you the ability to set maintenance windows. So check a box that says automatically go get these things and install them if you can during this specified maintenance window. And just kind of let this thing run and let it do its thing. Collecting telemetry for runtime estimates. Again, payload, we know. Workloads, we don't. I'd love to collect that telemetry data, get it back, and say, okay, based on you having 50 VMs, it'll take about this long. Based on you having 200 VMs, it'll take about this long. So you have to first opt into sending that telemetry data, and then we can parse it and make the service better. For more information, you can always go to Azure Stack Update or my Twitter handle, Justin I. So before I show you the UI real quick, what's the name of the file that you import that expresses the package details? Someone raise your hand. Yes. Close. Manifest.xml. Anybody else? Yeah. Metadata XML. You want a free t-shirt, my friend.
I do want it. Can I have it right now?
Yes. Love that guy. All right, good. What are the two vectors involved in determining runtime? Anybody? How long is the update deferral policy? So payloads, workloads. How long is the update deferral policy? You. I saw you first. You don't have to be as excited as the other guy. I get it. It's too early for that, but I'm glad he was excited. So where do you import them from? Right, you'll get the notifications from your OEMs. Thanks for your time. Let me show you guys the UI because we still have a few more minutes. Please provide your feedback to the Azure Stack team. Chung, myself, the rest of us, we love to hear that feedback. You can join the customer research panel, AKMS AZS session. Please evaluate this session. So that's screenshots of the portal, but let me show you the real deal. So here's our dashboard. You can see that we have an update available, right? And it shows me that particular version string. I can click on Update Available, and what it's doing now is parsing metadata.xml, that guy, and it's going to parse the metadata.xml and give me things like the name of the update package, the size of the update package, any prerequisite that the package might have. And when the package has run, it'll tell you details about that run. So we'll see the actual package, and you may have under the publisher column, insert your OEM here, right? They'll have OEM extension packages that get updated into the URP, just like we do for software update packages. We sign them, hand them back, they get parsed and run. So you'll actually have this. It's literally, you click on this update, and you can either right-click it or click Update Now, and it just kind of runs through the process. So I don't want to click Update Now because we have other PMs using these demo racks, so let me flip over back to the slides and show you what that looks like visually. So those are the three artifacts that will download and update, right, through blob service. And what that does, again, is it takes those from the blob service because we can't, as administrators, get into the infrastructure file share. It'll move metadata.xml to an infrastructure file share. It'll move the exe. It'll move the bin files. And then we invoke Cloud Update. It unpacks all those things and stages the cabs, stages the NuGets, parses the custom action plan, and starts the update process. So those are the three files that you need to update. You'll see that an update's available once you go through that manual process and import the updates. Once you run it, you'll see an in-progress status, state installing. You can click on that in-progress state, and you'll actually see the update run details. It'll show you things like steps that have succeeded, any errors to in progress, right? So if an error happens, it will actually revert the portal to a needs attention state. And it'll tell you with the download full logs button on what step it failed. So you can call into CSS, open a support ticket, remediate the issue, right, through the privileged endpoint, fix the issue, resume the update. More steps have succeeded. When it's done, you get completed, and it simply says applied successfully. You can go back to the portal, and you can see there's a filter. It's a little bit hard to read, but just next to engine update to the left, there's a drop-down box to show you available updates, installed updates. And you can filter because over time, you'll have a list of updates that have been applied, and maybe your security department comes back and says, hey, Chung, I need to make sure that KB blah, blah, blah is imported. That was part of the 1711 package. Have you installed that on your Azure Stack system? Chung can flip back to applied updates, look and say, oh yeah, that was applied, and go on from there. So that's what the UI looks like. I don't have a ton of time for questions, but we do have 6 minutes left. So thanks for your time. And then if you have any questions, you're going to know about deployment or security and anything else, Chung's up here too. So if you have any questions, please come up to the microphone and I'll be happy to take them. Did. Any questions? Yeah, see you, Steve. Happy? Yeah, please. I think your mic's dead. Maybe come up to this one.
Yeah, it's on.
Okay, sorry.
The updates that the RP gets, what about scenarios where the machines don't have access outbound to the internet? Can we inject that update into the stack?
Yes,
Okay.
absolutely. The Azure Stack doesn't need to be connected to the World Wide Web, but you need to have like a laptop or something you can connect to Microsoft and download the signed package and then carry it over to your Azure Stack, put it on a thumb drive, whatever you need to do, so you can import it through the containers. Once you import those 3 pieces through the containers, it'll show up in the UI as available. And thanks, if you guys got a blast, thanks for coming to the session. Yes, sir.
Is there any limitation about physical coupling, the number of nodes we can have into a single stack instance?
So nodes, so is there a number of physical nodes that you can add? I think we start out with 4s, 8s, and 12s for GA. Once we go past GA, we're implementing the ability to add additional nodes to the instance that you can purchase.
Depends on the our OEM partners. Some of them actually offer more incremental number of nodes. Some of them are offering the chunk of the 4, 8, 12. Some may even actually you can order 5, 6, 7.
Yeah.
But like what Justin was saying, the ability to add additional nodes, this will come in later.
Yeah.
Currently, if you go onto our publicly published white paper, that roadmap is currently specified at calendar year 2018.
Awesome.
So when you're planning for your production ordering, we recommend that you plan out capacity for the next 8 to 10 months, so that you don't have to worry about adding node. But adding node is certainly a critical feature that we're adding immediately after our GA.
Okay. So probably it's possible, instead of deploying multiple sites, just to put in place multiple instances into the same region and manage that separately.
So yeah, so our current GA scope only support one scale unit, one single region. If you have needs to multiple regions, then yeah, the only solution at this point would be you have multiple instances of Azure Stacks across the different regions. Yeah.
Yeah, you'll see the single region management here.
Right.
Yeah, it's good.
But going forward, we will add ability to add multiple regions management, but that's again calendar year 2018.
Yeah. Thanks, Chung. Mark, you were going to say?
Yeah, you mentioned about in the future release we will be able to set maintenance schedules.
Yes.
What happens if an update is still running and we're reaching out of the maintenance window? And the other thing is, why should I care about maintenance window if it is non-tenant interruptive?
Yeah, so the first question, good question, Mark. So if I set a maintenance window that I set for 8 hours and the update takes 8.5, does it stop? We've yet to design that. Are we soft, kind of like we are with affinity rules? Yep. And do we say, okay, if the update is going to take 10% more than our scheduled maintenance window, is that okay? What's that envelope look like? So we'll design that. And your other question is great. I love that question. Why do we care how long it takes? Why do we care about our maintenance windows? Some corporate IT, some service providers, maintenance windows are a must-have. You just have to do it. Anytime you're on the stamp, even if it's like monitoring and, oh yeah, I'm just going to go in there and pull a log file. Nope, you've got to set the maintenance windows. So set your maintenance windows regardless of policy and regardless of what I tell you, just to make sure if there is a disruption to one of those wild VMs that we can't live migrate gracefully or even do a quick on and we have to power it off, that scenario could happen in a forced drain.
Okay.
Yeah,
Thanks.
It's a good question, Mark. Yes, sir.
I have a question. Let's say you're deferring updates. The last one you got was 1708, and 1710 comes around and out-of-band update comes out afterwards?
Yes.
Would you have to update all the way to 1710 first before you apply the out-of-band?
No.
Or is that going to be out?
Yeah, that's a great question. So in that security zero-day exploit out-of-band scenario, we want you to just be able to apply it. Okay. We're not going to institute a prerequisite.
And I would assume that would just be included in the 1711 then.
That's right, and then we'll roll it in the next one. So for customers that may not be using a particular feature or may not be as exposed as others, or they're air-gapped, that may not care as much, they'll just get it for free, and we'll roll that forward into the next update.
All right, thank you.
Yeah, thank you for coming. Yeah, yes, sir. Yes, sir, down here.
Yeah, hi. The single node, like developer edition, the one node thing.
Yeah.
Does that have the similar process, or is it a case of rebuild every time there's a new addition out? 'Cause
Yeah.
obviously a single node.
Right.
Yeah.
The ASDK does not allow you to run PNU because there's nowhere to put all those VMs. But they will stay in lockstep with the PNU work streams. And so updates that we pack into a multi-node update will get applied to the ASDKs. And the ASDKs have a new baseline that just gets re-imaged and sent out to you all. So you all will stand up a new instance, brand new install of ASDK that should be, from a security perspective, apples to apples with an updated multi-node, because the payload's going to be the same.
Sure.
Yeah, good question.
The driver firmware update for the hardware path if it's a non-OEM. So since you're allowing the OEM to kind of integrate the driver firmware package into your payload,
Yeah, just the drivers.
and the firmware
Firmware
updates
is managed through the HLH.
Okay.
Yeah.
So with the drivers, if it's a non-OEM vendor, what's your
We get them from one of the vendors that we're working with. This is going to be Dell, HPE, Lenovo, Cisco, right? They're going to go get them from Mellanox. They're going to go.
Are you only supporting OEM?
Yes.
Okay.
Yes. Good question. Yeah. Yeah. Yes, sir. I can hear you. Go ahead.
How is all the rest of the hardware to the Azure Stack with the switches and besides and update?
Yeah.
Process to update that.
Yeah, so the question was, what about the switches and what about the firmware? The OEMs are responsible for the firmware update via the 5th node, if you will, hardware lifecycle host, or HLH. They're also responsible for guiding you, depending on vendor, because the switch will be different, on updating that switch. P&U, the umbilical in Azure Stack, will update the software of Azure Stack, all of ours, including parsing the OEM extension pack that has a driver in it from our OEM partners. But switch and firmware, my OEM friends handle that one. Yeah, good question. Thanks everyone for coming out. I appreciate you taking the time with me. Have a good rest of your conference.